Hello everyone. Today I'm going to be talking about reflection and refraction. First, we're going to begin by focusing on reflection so that we can gain a better understanding of how reflection helps us to understand the nature of rays of light. The first important thing for us to understand is that when we see an object, we are actually seeing light reflected from that object, allowing us to see the image of it. That's very important for the law of reflection, which states the angle of reflection is equal to the angle of incidence. And we'll come back to that soon to understand that better. But before we can do that, it's important to understand that there are various materials in life, some rough on the outside and some smooth. For example, my clothes, my skin is a rough surface, which is why we can see that with our eyes by looking at it from any angle that you see me. You can see what I look like. That is because light is diffused when it reflects from a rough surface. This causes many parallel rays of light to reflect at different angles. Whenever that happens on a rough surface or a rough material, we're able to perceive that with our eyes to see the image in front of us. On the other hand, a mirror, for example, is a smooth surface. Since a mirror is smooth, it will reflect the rays in only one direction, which is why we can only observe the reflected light at a particular angle. For example, if you've ever looked at a mirror, well, I'm sure you've all looked at a mirror, but depending on what angle you're looking at it, you can see certain things in the reflection. If you look at it straight on, you can generally see yourself, but if you're at an angle from the side, you can't see yourself in the mirror. Generally, you see what's on the opposite side from you at that same angle. And so now we're going to discuss why you see something from the exact opposite angle from yourself. And so on this diagram I have here, first it's important to understand that this point right here on the surface is where our light is hitting the material or the surface. And so from here on image 1, this perpendicular line is also very important to understand. Even though we may not have perpendicular lines actually coming out of the materials we see in real life, this perpendicular line to the surface is essential for understanding what angle our rays are making whenever they go in and reflect out. And so this image shows when a light ray reflects off of an object, how the angle of the rays of light are measured relative to the perpendicular of the surface. From this image, we learn that the law of reflection shows that the angle of reflection on the right is equal to the angle of incidence on the left. And so to even better understand this, the incident ray that we see right here is the ray of light coming into our object, represented by this arrow right here, whereas the reflected ray is the ray of light leaving our object. It leaves at the same angle from the perpendicular that our incident ray entered. And so right here we can see labeled, we have our angle of incidence with our little eye on the side of our incident ray, and our angle of reflection on the side of our ray that's being reflected. And so something that is essential to understand from this is that each angle is measured from the perpendicular line to the ray. So we never measure from the surface to the ray. It's always from the perpendicular line to the surface over to our ray. And our incident ray will be equal to our reflected ray. All right, now we're going to discuss refraction. So it was really important that we first had that base understanding of reflection, because some of those same concepts that we just discussed are now going to transfer over to refraction. So the first thing that we should understand is, what is refraction? So refraction is the change in the direction of a ray of light, often loosely called bending, when it passes through different media. And so we're going to talk more about what that means, but it's also important to note that the speed of light, which we've come to know as the constant c in many of our equations that we use, affects refraction as it is altered by the material it traverses. And so that's really important, because that's how we're going to really be able to measure refraction and how it affects our angles that our light rays are traveling at. And so right here we have the classic image of someone looking into a fishbowl. And I'm sure many of us have done it, where you look in at an angle and it looks like there are two fish from the corner, but whenever you move over to the side, you realize it's really just one fish in the bowl. And I know I've thought, well, why is this happening? What's going on? And it's because of refraction. So with the phenomena of looking in a fish tank and seeing these two fish, when there's actually only one, we learn that this is the result of refraction, because the fish appears to be in two different places. And that's because the light changes directions when it traverses from water to air, which are two different medias in this example. The light reaches the viewer by two different paths. Therefore, we see two fish. We recognize this bending of light to be refraction. And so if you've ever wondered why you're seeing two fish, now you know it's because of those two different paths that the light is taking as it traverses from water to air. So in our next image, we're going to look at the equation that represents the index of refraction. And so right here we've got n representing the index of refraction, our c, which as we just talked about is the velocity of light, so the speed of light, and then v is our velocity of light in a medium, like air or water or many other things that light can travel through before we see it. And so just like reflection, refraction is also measured relative to the perpendicular line coming out from a surface where the light ray crosses. But a significant difference to understand is the angle on each side of the perpendicular will not be the same. Whereas before with reflection, we saw that our angle of incidence and our angle of reflection were both the exact same. But in this example, our angles will not be the same. We're going to talk about why that is. But with refraction, the change in direction of the ray of light will be determined by how the speed of light changes between the mediums. This is related to the indices of refraction of each medium, as we saw in our equation. And so each different thing that something travels through has a different index of refraction. And so we're going to talk about how we can calculate that at the end of the video, and we're going to do an example of that. In regards to how the angle relates to the speed of light in the medium, the direction of the ray moves closer to the perpendicular when the speed of light slows down. This tells us if the speed of light decreases, then our angle also gets smaller. To the same degree, our ray moves away from the perpendicular line as the speed of light increases in the medium. So the greater the speed of light results in a greater angle between the ray and the perpendicular. And so you'll see that between things like, as you could guess, gas and air, things like that, light travels through with that, different refraction than it would through something like a diamond or another gemstone or material that's more solid but still allows light to travel through it. So the law of refraction, or Snell's law, shows us that the change in direction of a light ray depends on the incident angle and the change in speed of light between mediums. So now we're going to talk about Snell's law, this law of refraction. What is it? So as we just talked about n, our index of refraction, now we're going to convert that into this equation, which is n1, so our first index of refraction, times the sine of our angle 1 is equal to the second index of refraction times our sine of angle 2. And so here's a nice little diagram where you can see that these angles are not exactly the same. And so we can imagine that this is a medium that allows our speed of light to be greater because our angle is greater. So maybe this is air and maybe this is water according to the coloring, because in water the speed of light would not be as fast as in air. And so the equation to Snell's law, n1 and n2 represent the indices of refraction as we just said for each medium, and the angle 1 and 2 are the angles between the rays and the perpendicular line, just like in reflection. That same angle, just they're not equal this time. Just as with reflection, our incoming ray is called the incident ray and outgoing refracted ray, which is the difference. It's not the reflected, it's the refracted ray. And our angles are called incident and refracted. It shows that a large change in speed causes a large change in direction of our ray, which results in a large angle change. And so that's what we keep going on about. These angles will not be the same in refraction. And so now we're going to just do a couple of calculations, a couple of examples, just to make sure that we're all comfortable with this concept. And so the first refraction problem, we're going to use our first equation that we just discussed. And so if you want to pause the video right here, I'll give you a couple of seconds to go through this, and then I'll show you how you can solve this. Okay, great. So what we're doing for this problem is calculate the speed of light in zircon, a material used in jewelry to imitate diamond. And so here I provided the n already for us, the value of 1.923, and we should know what the speed of light is. And so we're going to use simple algebra to rearrange this equation so that we can solve for our velocity. And so if you guys did this correctly, you should have gotten velocity is equal to the speed of light over our n value. Set it up just like this, a very simple equation. And by plugging that into a calculator, you should have gotten that your velocity was equal to 1.56 times 10 to the 8th meters per second. And that's the velocity. Very simple calculations for this first part. And one other problem that I would like to do is this one right here. Once again, you can pause it and run through this calculation really quick. Okay, so we're going to find the index of refraction for medium 2, assuming the medium 1 is air, and given the incident angle is 30 and the angle of refraction is 22. The index of refraction for air is taken to be 1 in most cases. So here we have our 3 values. We're going to use the equation that we already had. The n1 sine of our angle is equal to the n2 sine of our angle. And once again, we can use algebra to rearrange the equation to solve for our other n value that we weren't given. And so if you guys set it up correctly, here's the original equation. You can change it so that we're solving for n2 by setting it equal to n1 times the sine of angle 1 over sine of angle 2. You can put in each of the numbers, and then you'll end up getting this. Once again, simple calculation, and you should have gotten 1.33. Okay, thank you guys so much for watching the video. I hope you have a wonderful day.